I'm going to show you 3 steps, but not simultaneously. We're gonna show you 3 steps, but I'm going to move from board to board between the 2 steps. Now when we get to the 3rd step, I'm going to have to erase everything on the first board, so just remember that, okay? Alright, first step. They want you to solve in slope-intercept form. Okay? What that means is I need to solve for y. So I'm going to take this 2x minus y equals 1, and I'm going to solve it for slope-intercept form. Slope-intercept form. So what that means is y equals mx plus b. That's all that means, okay? So, I need to solve for y. To solve for y, I need to move the x. So I got negative y equals negative 2x plus 1. Is y by itself?
Yes.
No.
How? Well.
It has a negative in front of it. It's tricking you.
Yeah.
It's almost a lump. Okay? So, everybody on the block gets the paper. Y equals 2x minus 1. Okay? So this is slope-intercept form. Just like we did in chapter 7. But I need to do it again for this one. So I need to subtract 3x, and get 2y equals negative 3x plus 12. Okay? And then I get what? Divide by 2, divide by 2, divide by 2. Everybody on the block gets the paper. Y equals negative 3 halves x plus 6. Okay? So, are the slopes the same? No. Is M1 equal to M2? No. No. The slopes are different. What does that mean? Slopes are different. What does it mean?
Slopes are different.
So what does that mean? They're constant. Consistent. Sure.
So they'll only have one solution?
One solution. What does it mean? The slopes are different. If I'm going in the same slope, I'll never touch. Or I'll always touch. But if my slopes are different, I can only touch one time. One solution. That's all it tells me. That's it. Okay? Now let's take a look on the next board.
I got a question.
Okay.
Now, okay, I'm trying to figure out, where did you plug in the y equals 2x minus y? You didn't, right?
Where do I plug in what?
Okay, we solved on the slope-intercept.
Oh, I didn't plug
form.
anything in yet.
Nothing yet?
Yeah,
Okay.
you told me to do
Okay.
one step at a time. So I'm doing one step. This is it. That's the first step.
So where did you get the, okay. I
So
was
what
writing the notes, okay. So all you're doing on the bottom one, you're just trying to get y by itself again over there, right?
That's it.
The second, okay.
What this does, is when you get it in slope-intercept form, is it tells you whether or not they're parallel or they're the same line or they intersect. That's it. if they intersect, this tells me if the slopes are different, then they intersect. If they intersect, there's one solution. Okay? The slopes are different, then they intersect. If they intersect, then there's one solution. Questions? All right. So, the next part of the problem. It doesn't stop there. Right? If they intersect, where do they intersect? Slope-intercept form is only telling you what happens. It doesn't tell you where it happens. Okay? So what tells you where it happens? What can you use to figure out where something happens? So we can use two things. You can use a lot of different things, but I only teach you two things. One is substitution. The other is linear combination. Okay? I'm going to show you substitution first. Okay? Substitution. I've already shown a lot of linear combinations. I want to show one substitution. So, first of all, I'm going to write the equations again over here. 2x minus y equals 1 and 3x plus 2y equals 12. Then I'm going to rewrite those so that they imply y equals 2x minus 1, and this implies y equals negative 3 halves x. Is that right?
Mm-hmm.
Plus 6?
Plus 6.
Okay. So these are our two lines. This is just this rewritten. This is just this rewritten. Okay? So if I grab this, which looks like my best one, because who wants to grab one with a fraction? That's just going to, make it really complicated. So let's grab one that just has whole numbers. If I grab this, I cannot put it here. Can't. Why? It just tells me that it'll say that, yeah, 1 equals 1. Because it's just saying the same thing. This is this line. It's nothing different about it. So where I have to plug it in is here. The other line. If I grab this one, I have to plug it in the other equation. Okay? That is a must. So how will it look? 3x plus 2 y, which is 2x minus 1, equals 12. So this is substitution. Okay, so plugging this in. All right.
Okay, gotcha.
Got me?
Gotcha, yeah. What are you gonna do?
All right, so from there, I got to do the math. Everybody on the block gets the paper. 3x plus 4x minus 2 equals 12. So then, I collect my like terms, and I get 7x minus 2 equals 12. Then I solve for x. Plus 2 plus 2, 7x equals 14. divide by 7, divide by 7, I get x is equal to 2. I already know that there's a solution, and this is half of my solution. Why is it half?
So then you have to go plug it all back in, don't you?
Yes, but why is it half of the solution? Because yes, and there's how many variables? 2. 2, and I solved for 1. 1 over 2 is a half. So it's half of my solution. I have one variable. I need to get the whole solution by getting 2 variables, x and y. So, the cool part is, this problem, unlike that last one that was all confusing but is real in real life, this one came out all nice and neat and is not real in real life, but it's convenient. Okay?
Very.
So, what do I do next? I'm gonna go to the other board. I'm still not done with that problem though. I'm just taking it to a new board.
This is a substitution, right?
Yeah, we're still on substitution.
Okay.
We're still on substitution. It's the second layer of substitution. Now, like the last problem, remember that you got upset with? That problem was more real life. Why? Why was it more real life?
So you'd have to substitute.
Ah, if I were to substitute the problem, it was a fraction. And they're nasty, but that's what happens in life, right? This problem's a whole number. So because it was a fraction, I decided to do linear combination, right? But I don't have to now, because that's a fraction. So I think that's what you were looking for, right? If I have a fraction, I don't want to plug in a fraction, so I'm going to use linear combination.
So linear combination is substitution and
A linear combination is getting rid of a variable, right? It's getting rid of a variable by adding 2 linear equations, two variable equations, and getting rid of the variable that you don't want. In this case, I have x, so if I wanted to choose linear combination, I would choose to get rid of what variable? I already have x, so what variable would I get rid of?
y.
No. Sounds logical, but it's not.
X.
I would get rid of x. I already have it, so get rid of it.